Good evening, friends. My name is Chalaru Sirachi, and today I am here to present the Zener diode tester, which is guided by Mr. Chandrasi Parmar, head of ICT department. So now let's see what is the Zener diode tester. What is Zener diode tester? Basically, Zener diode tester is used for checking the Zener diodes of 3.3 volt to 18 volt. The breakdown voltage of the unknown Zener diode is indicated on the pre-calibrated dial of potentiometer. The tester can also identify the polarity of Zener diodes. So now let's see which will components will help us to make the Zener diode circuit. The components to make the Zener diode circuit are as follows. First of all, we need the transformer. Second, rectifier diode. Third, filter capacitor. Fourth, resistors. Fifth, transistors. Sixth, Zener diodes. Seventh, potentiometer. And lastly, LEDs, which will help us to see the perfectly output. The Zener diode allowed us current to flow from the anode to cathode, and at the same time blocking the current from flowing in the other direction. If the power is connected in the wrong way in a circuit, then the components are protected from damage by the Zener diode. In this way, Zener diode can protect our components like LED. The diode protects the components by blocking the current flow, thus avoiding damage to be caused. The Zener diodes are used in changing current from alternating current to direct current, which means AC current to DC. When the linear potentiometer VR1 is adjusted such that the voltage at its wiper arm exceeds the breakdown voltage of the Zener diode. The Zener diode conducts and applies the bias voltage at the base of transistor T2, which causes red LED to light up. For calibration of the Zener diode tester, initially set the pointer to the knob of the potentiometer, that is VR1, towards zero resistance position. Now rotate the pointer knob of the potentiometer VR1 slowly in the clockwise direction until LED just starts to glow. Short red clip of potentiometer and black clip of the transistor and switch on the tester. If the Zener diode is connected in reverse polarity, then red clip to the anode and black clip to the cathode LED glows brightly at all settings of the knob above the zero reading, indicating that the Zener diode is wrongly connected. The anode and cathode terminals of rectifier diodes can also be identified in this way. And do not touch the clips while testing the circuit. So now, this is the circuit of our Zener diode, which is created in multisim. Now let's see the circuit in detail. So friends, this is our circuit in multisim, which is made using transformer, transistor, diode, capacitor, multimeter, resistor, and key and also a ground. So now let's check the circuit in detail. So first of all, this is our AC power, which has 230 volt and 50 hertz, which is connected to key and also ground. And they both are connected to a transformer that has ratio 909, The primary coil 1 has 9 turns. Secondary coil 1 has 0 turns. And secondary coil 2 which has 9 number of turns. And this transformer is connected to a diode, that is 1N4001G, that is 1 ampere 50 volt standard rectifier. Now this diode is connected to a transistor BC547BG which has NPN transistor. So now this transistor is connected directly to the two Zener diodes, that is D2 1N5925 and another one D3 1N5925B, and second, this diode is connected to resistor which has 1 kilo ohm in between the BC547BG transistor, and this resistor is also connected to the capacitor, that is 220 microfarad. Now the another part of BC547BG transistor is connected directly to the another resistor, that is R2, which has value 1 kilo ohm, and that resistor is directly connected to the red LED. And that LED is connected to another transistor, that is Q2 BC547BG, which is connected to the diode, that is D5 1N4446. So this resistor R2 1 kilo ohm is also connected to another resistor R3 which has value 2.2 kilo ohm, and that resistor has been connected to the another potentiometer which has value 500 ohm. Which is increased to 80% off. So now we have taken another diode, that is 1N4446, for checking the voltage across it. That's why we have put one multimeter across it. So now let's run our circuit. So first of all, we will plug in the key. Now let's run. As you can see, there is 16.5 and it varies from time to time. Now let's stop this circuit and change the value of resistance. Let's make it to 3 kilo ohm. Now let's run circuit again. As you can see friends, the voltage has been increased to 16.9. Now again let's change the value of resistor. Now this time let's make it to 5 kilo ohm. Now the value has been changed to 17.3 and it varies from time to time. And when we plugged off the key, then value will also change. As you can see, it has some value in negative value, that is minus 0.001. So when we plug on, the value will be in positive, and also LED will blink. So friend, this was our Zener diode circuit. Now at last I would like to thank our Parmar sir to guide me in this project and circuit as well as. So thank you, sir, and thank you, friends.